Hi students, welcome to the class Mathematics. In the last two classes of the chapter Mathematical Reasoning, we discussed the different terms such as statements, compound statements, truth tables of the compound statements and their negations. Now in this class, we are going to discuss how to answer the questions given from the chapter Mathematical Reasoning. Students, now let us see this question. The converse of the statement, if two triangles are congruent, then they are similar is. So here, for the given statement, we have to write the converse. If you observe the given compound statement, we can say that it is a conditional statement because this compound statement uses the connective if then. That's why it is conditional. Now let us see the different forms of conditional. If you take the conditional of the statements P and Q in the symbolic form, we will write P implies Q, which means if the statement P, then the statement Q. Here in the conditional, the first statement P is called hypothesis and the second statement Q is called conclusion. Now, if you interchange hypothesis and conclusion, you will get converse of the conditional. So, to get the converse, we have to interchange the statements hypothesis and conclusion. So, Q will be hypothesis and the first statement P will be conclusion. This form of the conditional is called converse of the given statement P implies Q. Now, with the help of this form, we can easily write the converse of the given compound statement. So here, in this given compound statement, the two triangles are congruent is the hypothesis and they are similar is conclusion. So by this form, we have to write conclusion as hypothesis. What is the conclusion here? They are similar. So that statement is written as hypothesis. Now let us write the converse of the given statement. If two triangles are similar, then what is the hypothesis? The two triangles are congruent is the hypothesis. Now we are going to write that hypothesis as conclusion. That's why after that we have to write they are congruent. So the statement thus we have got, of course what we have done, we have interchanged hypothesis and conclusion. So after interchanging the hypothesis and conclusion, we have got this statement. This compound statement is called converse of the given conditional. Students, now let us see this question. If the truth value of a statement P implies negation Q or R is false, then the truth values of the statements P, Q and R are respectively. So, here to find the truth values of the statements P, Q and R, first we have to take the given condition. What is the given condition? Given that the truth value of the statement P implies negation Q or R is false. Here if you observe, this is the conditional of the statements P and negation Q or R. But we know that the truth value of the conditional statement is false in only one case. What is that? If the first statement is true and the second statement is false, in that case their implication will be false. That's why here we can say that the first statement has the truth value true. That's why truth value of the statement P is true and the truth value of the second statement negation Q or R is false. So here we have got the truth value of the statement P. Let us see the second statement. that is negation Q or R is false. But this is the disjunction of the statements negation Q and R. But we know that disjunction of two statements is false only in one case. That is, when both the statements are false, their disjunction is false. That's why here we can say that the truth value of the statement Q is false and also the truth value of the statement R is false. Now we have got the truth value of R also, that is false. Now we have to find the truth value of the statement Q. But here we have got that the truth value of the negation Q is false. But we know that if the truth value of any statement is true, the truth value of its negation is false. And in the same way, if the truth value of any statement is false, then the truth value of its negation is true. That's why here the truth value of negation Q is false. So we can say that the truth value of the statement Q is true. So finally we have got that the truth values of P, Q and R as true, true and false. This is the true, true and false means first option is correct option. Students, now let us see this result. Remember, this result is very useful for us to solve some of the problems in mathematical reasoning. Now let us prove how these two compound statements are equivalent. So what is meant by equivalent statements? If two compound statements have the same truth values in all the logically possibilities. So for that, let us prepare the truth table for these two compound statements. For that, first we have to identify how many different statements are there in the given relation. Very clear that there are only two different statements, that is P and Q. That's why first let us take two columns headed with the statements P and Q. And for any two statements, how many different possibilities are there? There are four different possibilities. What are they? Both the statements true and true. P may be true, Q may be false. P may be false, Q may be true. And both the statements may be false and false. These are the cases for any two statements P and Q. Now, after writing the possible cases for these two statements, let us see if any negations are given for any of the statements. Yes, for the statement P, negation Q is given. That's why you take another column with negation P. Now, let us write the truth values of this statement also with the help of the truth values of the statement P. As P is true, we can say that negation P is false and also it is false. As P is false in this case, negation P is true and also it is true. After writing the truth values of the negation P, let us find the truth values of the compound statement P plus Q. So let us take another column headed with P plus Q. But we know that P plus Q is false in only one case, that is P is true and Q is false. You see that we can see only in this case. P is true and Q is false. So in this case, P plus Q is false. And in the remaining all the three cases, P plus Q is true. That's why P plus Q is true, false, true, true. After that, let us find the truth values of this compound statement negation P or Q. Now we have to find the disjunction of the statements negation P and Q. But we know that disjunction of two statements is false in only one condition, that is when both statements are false. That's why here from these two statements, let us search for false and false case. This is false and false case. this is not false and false case. Only this is false and false case. So in this case only the disjunction of negation P or Q is false, and the remaining all the cases it is true. Now if you observe the truth values of P implies Q and negation P or Q, we can see that both are equal. You see, true, true, false, false, true, 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 true. So TFTT and also TFTT. So these two statements have the same truth values in all the logically possibilities. That's why we can say that these two statements are equivalent. That is, P implies Q is equivalent to negation P or Q. Students, let us see the next one. The statement P implies Q implies P is equivalent to. So here four options are given. We have to see to which compound statement the given statement is equivalent. For that, we have to use mainly two results. What are they? The first one is P implies Q is equivalent to negation P or Q. This result we have discussed in the previous question. So what are the changes we can observe? P became negation P, implies became or, and Q remains the same. And the next one is T or statement P is equivalent to T. What does it mean? What is this T? T is the statement which is always true. Now let us see how T or P is always true. With the help of truth tables we can easily decide. T means always true. For P there are two possibilities, either true or false. Now let us write T or P, that is disjunction of the statements T and P. Disjunction is false only when both the statements are false. But here there is no case in which both the statements are false. Okay, that's why here T or T is T, T or F is also T. So like that here the statement T or P is always true statement. That's why we can say that T or P is always T. Now by using these two results we can easily find out its equivalent compound statement. Now let us start with the given statement P implies of Q implies P. Now if you apply the first result, what can you write? First statement is given negation and this implies becomes or, and the second statement remains the same. So we have got negation P or Q implies P. Again for the second statement Q implies P, let us apply this rule. So with that rule, first statement Q becomes negation Q, implies becomes or, second statement P remains the same. Now negation P or, this is the disjunction of two statements, but we know that disjunction of two statements is commutative. So we can write this statement as P or negation Q. And also we know that disjunction of the statements is associative. So we can write this statement as negation P or P or negation Q. And once you observe this statement, negation P or P is always true statement. Because if you say it is a marker or not a marker, such a statement is always true. We already discussed this point at the time of tautology. That's why negation P or P is a true statement. That's why here we can say that T or some statement negation Q is always true statement with this. T or some statement P is true. Like that here also T or some statement negation Q is true. We can replace this statement by its equivalent statement T or Q. Though you take T or Q, T or negation Q, both are equivalent statements. If not, if you find the truth table of T or negation P, it is also true. That's why these two statements are equivalent statements. That's why we can replace this statement by T or instead of negation Q, I have written Q, no problem. Their disjunction is also true. Now, by using associative, I am rewriting this statement as negation P or Q. Now, with the help of this result, again let us write in the reverse form. So, negation P or second statement. This can be written as P implies P or Q. P implies P or Q is the second option. Students, the next one, the negation of the statement negation yes or negation or and yes is. So to find the negation of the given statement, let us apply negation to the given statement negation yes or negation or and yes. Here, this is the disjunction of these two statements. But we know that negation of the disjunction P or Q is equivalent to negation P and negation Q. Here, what changes we can observe? These two statements are given negation and the connective or becomes and. So here also let us make the same changes. So let us give this negation to both the statements. That is negation of negation yes, this or becomes and, negation of the second statement negation or and yes. And also we know that negation of negation yes is the statement yes, and again this is the negation of conjunction of two statements negation or and yes. What is the negation of the conjunction? Negation of P and Q is equivalent to negation P or negation Q. Here, what are the changes we can observe? This negation must be given to both the statements P and Q, and this and becomes or. These are the changes we have observed. The same changes let us make for this statement also. That is negation of negation or, this and becomes or, negation yes. It means we have given this negation to both the statements and we have changed this and as or. Again, yes and negation of negation or is or, or negation yes. Now let us apply distributive law. Yes and or yes and negation yes. That is yes and or what about this yes and negation yes? Let us take some general statement. If I say it is a marker and not a marker, do you agree? No, because it is always false. That's why here also yes and not yes is a false statement. But we know that the disjunction of any statement with the false statement is the statement itself. For example, P or F. The statement P or F. Let us take. For the statement P, there are two possibilities, either true or false. For the statement F, always false case, because F denotes the statement which is always false. Now let us find their disjunction. But disjunction is false only when both are false. That's why F or F is F, but this is true. Once you observe the truth values of these two statements, P or F is equivalent to P only. That's why here also this statement or F is equivalent to the statement itself, yes and R. So the negation of the given compound statement is yes and R. That is first option. Students, the next one is negation of P implies negation Q is equivalent to dash. Now let us find out its negation. That is negation of P implies negation Q. But we already discussed the negation of the conditional. That is negation of P implies Q is equivalent to P and negation Q. Here the first statement P remains the same, implies becomes and Q is given negation. Okay, the same changes here also let us make to get its negation. So what is that? First statement P remains the same, implies becomes and this negation must be given to second statement negation Q. That's why here we will get negation of negation Q. Now which is equivalent to P and negation of negation Q. But we know that negation of negation Q is equivalent to Q. So this is the result which is equivalent to the given statement. Negation of P implies negation Q. So first option is correct option. Students, let us discuss some more problems in the next class. Thank you.